Welcome to T Academy. In today's lecture, we'll be seeing how to implement a NOT gate circuit. So a NOT gate, as you know, is given by this symbol, a triangle with a dot, and if we apply an input A to this NOT gate, we get an output A bar. So A could be a digital bit 0. In that case, the NOT gate circuit outputs a digital 1. If we input a 1 to this NOT gate, we get a digital 0 as output. So in today's lecture, we'll be seeing the circuit behind this NOT gate operation. So this circuit is something like this. We have a resistance RL in series with a switch. So this switch will be some sort of a transistor, but for today's lecture, we just consider it as a switch. And this is then connected with a battery VDD. The output of this circuit, V out, is taken across the switch, and the input to the circuit is the control signal which actuates this switch. So when an input signal is applied, it actuates the switch and the circuit then closes. Now let's say that the input signal that I apply to this circuit looks something like this. It stays 0 for a certain time, then it switches to a higher voltage, then it goes back to 0, stays 0 for a certain time, and then switches back to a high signal. So this is the input signal. It has two levels. So this level is V low and this level is V high. So in between, let's say in the middle, this level we call as a threshold voltage, V threshold. So whenever the input signal is less than this threshold voltage, we encode this signal as a digital 0, and wherever the signal is higher than this threshold voltage, we encode it as a digital 1. This is a very simple encoding. You can find more on this in my series on communication systems. You can find a lot of engineering courses on my channel, so feel free to take a look. But here, for the sake of this video, I am just implementing a very simple non-return to 0 encoding. This would be a 0, this would be a 1. So if you are interested in this type of encoding, you can check out NRZL encoding, which leads to this input signal, a digital bit stream of 0, 1, 0, 1. So this is what I supply as input to this circuit. A 0 basically meaning that there is no signal and the circuit stays open. A 1 actuates the switch and the circuit closes. So let's see what happens in these two different states. So in the first state, when the input signal is 0, the circuit looks something like this. A resistance RL, then the switch is open, so I have an open circuit here, and a battery VDD, and I'm taking the output across these open terminals. So as you can see that in this case, no current would flow through the circuit since the circuit is open. So all of this battery voltage VDD appears across Vout. So Vout is simply equal to VDD. Now let's check the other case when the input signal is equal to 1. So this means that in this case this circuit is closed. So we'll have the same resistance RL, and now these 2 points will be shorted. Then we have a battery here, VDD. In this case, these two terminals are shorted, so Vout becomes equal to 0. So let's see what the output signal looks like in comparison with the input signal. So this is the input signal which we just saw in the previous slide. So now let's plot the output signal Vout just below it. So as long as the input signal is low or a digital 0, the output is equal to VDD. So I can plot a high voltage level VDD here, and whenever the input is high, the output voltage is 0. So I get a 0 here, VDD here, and 0 here. So VDD 0. And if I apply the same type of encoding, that is the threshold is at a voltage level in between these two levels, then VDD would be encoded as a digital 1 and 0 as a digital 0. So the output bit stream would become 1 0 1 0 when an input of 0 1 0 1 is applied. So this is nothing but NOT gate operation which we have achieved using this circuit here. So I hope today's lecture was useful. If you like my content, then please do subscribe to the channel, and I'll see you again in a new video. Bye.